As a developer, you know the frustration of installing countless packages on your machine, cluttering it with dependencies you might never use again, and dealing with version conflicts that seem impossible to resolve. But what if I told you there's a way to develop any project without installing a single programming language or framework on your computer? Today, I'll show you how VS Code's dev containers can solve these problems, requiring only Docker and VS Code to be installed on your system. When you develop with containers, every project lives in its own isolated environment. Your container handles all dependencies, configurations, and tools, while your local machine stays clean and organized. To begin, you'll need Docker installed and running on your system. Next, open VS Code and install the Dev Containers extension from the marketplace. This extension will be your gateway to containerized development. Let's say you're building a Python application. You haven't installed Python on your local machine at all, and you don't want to because you want to avoid dealing with package dependencies. With Docker and Dev Containers, you don't need to install Python locally. Here's what you do instead. Open the command palette with Ctrl+Shift+P on Windows or Command+Shift+P on Mac and type Add Dev Container Configuration Files. VS Code will present you with two options. Add configuration to workspace or Add configuration to user data folder. I recommend always choosing Add configuration to workspace. This creates a dev container folder in your project directory instead of your user directory, allowing different container configurations per project. Next, VS Code displays templates for different programming languages and frameworks. Since we're building a Python project, type Python in the search field. You'll then see options for different Python versions. For this example, let's select the latest version, Python 3.12. VS Code will then guide you through additional steps where you can enhance your container with extra features. While there are many options available, we'll keep it simple for now and skip these by clicking OK without selecting any additional features. This process creates a dev container folder in your project. Inside, you'll find the dev container JSON file, the blueprint for your development environment. The dev container file is the heart of your dev container configuration. It tells VS Code how to build and set up your container environment. This image property specifies the base Docker image to use for your container. It should include the operating system, language runtime, and other core tools you need. In our case, it tells Docker to download the Python 12 Docker image and use it to build a container. When building a Python project, you'll likely need various modules to run your code. Typically, you'd install these using pip install in your terminal, followed by the package name, or more efficiently, by listing all dependencies in a requirements text file and installing them with pip install-r requirements.txt. With dev containers, you can automate this process by adding the installation command to your container configuration. Simply uncomment the postcreate command property in your dev container JSON file. This command executes automatically when your container builds, installing all dependencies specified in your requirements file within the container environment, keeping your local machine completely clean and unaffected. Another powerful feature lives within the customizations property of your container configuration. While your locally installed VS Code extensions don't automatically appear in your container environment, you can easily add them. Simply click the settings icon next to any extension in VS Code and select Add to Dev Container JSON. This tells VS Code to install that extension when building your container, making it available in your containerized development environment. For example, if you need extensions like GitHub Copilot, adding them to your container ensures they're ready to use as soon as your container launches. This way, your development experience inside the container remains just as good as your local setup. There are tons of other properties you can add to the container, which we will not go into today. Please check out the Dev Containers extension documentation for more information. Now that we've configured our development environment, it's time to launch our container. Open the command palette with Ctrl+Shift+P on Windows or Command+Shift+P on Mac and type Reopen in Container. Select this command and VS Code will begin building your development environment. You'll see a progress indicator as VS Code builds the container and establishes the connection. The first build will take several minutes because Docker needs to download the Python image. However, once this image is cached on your system, subsequent container starts will be much faster since Docker won't need to download the image again. Once complete, VS Code will automatically connect to your new containerized environment ready for development. Once your container is running, you'll see an indicator in the bottom left corner of VS Code. This tells you that you're working inside the container. All your commands, debugging sessions, and terminal operations now run in this isolated environment. Whenever you modify your dependencies or container configuration, you'll need to rebuild. For example, if you add new packages to requirements text file or modify dev container JSON, click on the remote indicator at the bottom left of VS Code and select Rebuild Container to apply your changes. When you're done working, you can close the container connection by clicking the remote indicator in the bottom left corner and selecting Close Remote Connection. This frees up system resources while preserving your container for the next session. Dev containers eliminate environment inconsistencies and keep your system clean. No more "it works on my machine" problems or dependency conflicts. When you're done with a project, simply delete its container and image in Docker Desktop. Your local system remains clean, with no leftover dependencies to clean up. Thank you so much for watching, and I hope you'll join me soon in my next video.